This is Module 10.4, Determining K from Experimental Data. We're going to start with simple problems where all the equilibrium concentrations are provided. Consider the below reaction. After equilibrium is reached, the concentration of hydrogen is 1.30 molar, the concentration of chlorine is 2.50 molar, and the concentration of hydrochloric acid is 0.25 molar. Find Kc. So the first thing we're going to do is write the equilibrium expression. So Kc is going to be equal to products over reactants raised to their coefficients. So HCl squared over the concentration of H2 over the molarity of chlorine. And then it's a matter of simply substituting in the values. So we have 0.025 squared over 2.50 multiplied by 1.30. And we put this into the calculator. We are going to be limited to two significant figures by the concentration of the HCl. So we're going to have 1.9 times 10 to the negative fourth. Now at this point you may be going, well, what about the units? When we were doing rate constants, we had to get the units for the rate constant. We consider the equilibrium constants to be unitless. This is not strictly true, but we get to ignore units. The reasons behind that have to do with why we ignore the concentration or why we ignore solids and liquids when we're writing equilibrium constants. So what we do is we just assume it's unitless, so life is much easier. Now here's the next question. Does the equilibrium lie towards the left or the right? Okay, so does it favor reactants or products? And if we look at our value of K, K is much smaller, so K is much smaller than 1. So little product is made. And if we look at our experimental data, we can see that when we were at equilibrium, the concentration of the hydrochloric acid was only 0.25 molar compared to the other values. So the equilibrium lies towards reactants. Okay, so this is when you're given a concentration straight out. Let's say instead that you are asked to determine K from a graph. Find the value of K for this reaction run at 75 degrees Celsius. There's our reaction here. So first off, let's just write our equilibrium expression. We have, and we're talking about molarity, so we're going to write Kc. Kc is going to be NO2 squared over N2O4. And then we're going to look at the graph and we're going to find the concentrations. And this is 0.120 and we have 0.040. We're going to ignore the earlier portions of the graph because before that we were in the little k region. Okay, so we're just going to ignore everything in the kinetics region. And we plug in our values. So Kc is going to be equal to 0.120 squared over 0.040. And we're going to have three significant figures in our answer, so it's 0.360. So when we're given the final concentrations, either as numerical values or from a graph, the values for K are very, very easy to calculate.